Hi, my name is Francisco Javier Diaz Islas, and I'm here today to present to you our design for the welded cell for my evidence. Well, first, talking about the considerations of security and technical safety that we took into account, we implemented safety mats, safety fences, and also the physical controllers with an emergency stop in order something goes wrong with the robot. We implemented this taking into account the possible risk that the workers might experience inside the cell. So, because also in the documentation we implemented some of safety measures that should be taken into account when operating a laser. But because the workers don't need to be in contact in a direct contact with the laser, we just redacted them in the report, but we didn't put anything in the simulation. So the fixture design, well, let me just zoom in. So this is the fixture design that we designed for the pieces. What we what we want to take into account when designing this fixture is that the workers know where to place it so the robot can weld the points correctly. So what we thought for the design is to make a bit of a mold, or well, more like a fence, a guiding fence that tells the workers where to place the piece. So for example, this piece right here, this bulk, works as a guide for the workers. They know that piece needs to fit in here. So we also implemented this part that allows the piece to lay on here, and also this part that allows the piece to lay on here. So we also design these holes for the robot to actually weld the welding spots that are behind the piece. So there are no complications at the time for the robot when it starts welding. We actually designed two fixtures, one for the right and one for the left. And the other one has a bit of a variation, but the concept is exactly the same. That functions as a guide and helps the workers to know where to place the piece. So next is explaining the design procedure and technical considerations taken in the adapter of the laser head. We actually didn't need to design an adapter because, as you can see here, uh, the the flange that was already in the design works perfectly. So we actually didn't need to design one, and we just fit it in Robot Studio, and it worked perfectly. It fit perfectly, and we didn't need to design anything. And last is I'm going to explain the technical considerations when taking account in the choice of the robot and the positioners. So first with the robot, we took into account the weight load and also the reach. The pieces lengths are about 2.75 meters in length and about 1.45 meters in height. So we chose a robot that could reach all the welding points with the positioners positioned in this way, but also we considered the load that the robot was able to carry. The laser head had a weight approximately around 5 and 6 kilograms. So we chose a robot could that would be able to actually carry that weight and also reach that distance to weld all the welding spots. So this is a robot. The robot we chose was a RB4660, and the two positioners were the RBPL 300. For the positioners, we wanted a positioner that was able to rotate completely the fixture and allow the robot to and that allow the robot to reach all the welding points without any obstructions. So these two positioners actually don't occupy too much space. So what we only needed to worry about was the fixture. And well, everything went pretty fine. So these are some of the sensors we implemented. For example, the rotatory table shouldn't be able to move unless there's not a human here. So that's what the safety mat is for, this one here. And also, the considerations we took for the machine system was that we needed something that allow us to detect possible failures or possible mistakes in the welding of the pieces. That's why we, for example, went for a vision system that was Insight D900. And according to the Cognex page, this type of vision system specifies in that detecting errors and mistakes, especially on assemblies and welding spots. So that's the why of why we chose it. And this was my evidence. Thank you so much.